students, so today we're going to look at operations with radicals. What you're going to want to have on you today, your notes, a pen or a pencil, and of course a calculator. So what we're going to look at, we're going to look at adding, we're going to look at subtracting, and we're going to look at multiplying, and we're going to focus a little tiny bit on dividing. But most of it, we're going to look at multiplying and adding and subtracting. So combining like radicals. What you're going to always want to have when you're adding or subtracting is you're going to want to have like radicals, aka you want these two numbers to match. So notice how it's the square root of 11 and the square root of 11. They are matching. So all I need to do is add the numbers in the front. So I could technically make this 6x plus 9x. Something like that. That way it's easier for me to figure it out. So 6x plus 9x, well that's 15x, right? And I know x is the square root of 11, just so I didn't have to see it. So my answer would be 15 square roots of 11. All right. Notice on this one, I have the same thing. I have square roots of 3's. So now what I'm going to do, I'm thinking that there's a 1 right there. So I have 1 square roots of 3 minus 5 square roots of 3. Technically, I can make this like this, so I don't have to think with that square root of 3 in there. So I'd have 1x minus 5x's. So that would be minus 4x, right? Which, if I re-put my x back in of square root of 3, I have my answer of negative 4 times the square root of 3. Pretty easy, right? Now, what if the radicals aren't the same? Which will happen majority of the time. You're going to want to make it so they are the same. So us breaking down the square roots, that's going to come in big handy today. So this square root of 12 right here, I notice I can break that down. So I know that's the square root of 4 and the square root of 3 in there, right? That's kind of how we've been doing it. So I'll get 5 square roots of 3 minus square root of 4 is 2. And then I have the square root of 3 attached, right? Well, notice, I now have the same radicals. Awesome. So now I can just subtract. So 5 square roots of 3 minus 2 square roots of 3, well, that is just 3 square roots of 3. Pretty simple, right? What about 4 square roots of 7 plus 2 square roots of 28? I can't break down the square root of 7, but I bet I can break down the square root of 28. A perfect square that goes into 28. Let's see, if I divide it by 4, I'll get 7. So I'll get square root of 4 and the square root of 7. So 4 square roots of 7 plus 2 times, what's the square root of 4? 2 square roots of 7. Well, I gotta combine this here. That's 4, right? So I'd have 4 square roots of 7 plus 4 square roots of 7, which if I have 4 square roots of 7 and I have another 4 square roots of 7, I now have 8 square roots of 7, right? Altogether, perfect. So adding and subtracting is not hard at all. You just need to make sure that you get the same radicals, and then just add the front numbers. What about multiplying? So multiplying is just a little bit stronger, a little harder to do, but not too bad. So you're going to multiply it in. So I'm going to have the square root of 10 times the square root of 6. I can make that the square root of 60. Okay? So you can multiply the radicands inside. Plus 3 square roots of 10. Now, I need to break down. We need to make sure that nothing can combine. Okay? So what's the square root of 60? I know I can make that the square root of 4 times the square root of 15, right? So I would have 2 square roots of 15 plus 3 square roots of 10. That doesn't break down at all. But always check to make sure the radicals you combine at the end does not break down, because it can happen. Sometimes it will. So that would be my final answer for that one. Let's try this one. Square root of 6 minus 2 square roots of 3 times the quantity square root of 6 plus the square root of 3. This is when either you're going to want to use box or FOIL. So if I use the box here, so you're going to write these on the outside. Square root of 6 minus 2 square roots of 3, square root of 6, square root of 3. All right? Square root of 6 times the square root of 6, that is the square root of 36. Square root of 6 times the negative 2 square roots of 3. I'm going to get negative 2 square roots of 18. Square root of 6 times the square root of 3, that is the square root of 18. And this square, negative 2 square roots of 9. Because the square root of 3 times the square root of 3. So, then I am going to write that out. I got square root of 36 minus 2 square roots of 18 plus square roots of 18 minus 2 square roots of 9. Square root of 36, we know that to be 6, right? Combine these two. I have negative 1 square root of 18, right? And negative 2 plus a positive. Square root of 9, that's 3. So I have negative 2 times 3, that is negative 6. Oh, look. 6's cancel. I am left with negative 1 square root of 18. Those are the longest ones. Those take the longest to work out just because of all the breakdown. We also need to break down the square root of 18. Almost forgot about that. So we would have square root of 9, square root of 2. So I would have negative 3 square roots of 2. All right? Now, this is when we're going to look a little bit at dividing, but not a whole lot today. So rationalizing denominators. You can't have radicals in the denominator. We've talked about this before. So what you're going to do is you're going to what's known as rationalize the denominator. So you're going to multiply by its complex conjugate. And you're saying, what's that? Well, I'm going to multiply by the denominator, except I'm going to change the sign in the middle. So notice how it's a negative here. I'm going to change it to a positive. Just like that. So then this 10 is going to distribute in. I'm going to get 10 square roots of 7 plus 10 square roots of 2. All over. This is when we're going to multiply this out here. What's really awesome though, it's going to cancel those middle terms. Because I would get the square root of 49. Square root of 7 times the square root of 2 is the square root of 14. Minus the square root of 14. Minus the square root of 4. Okay, so I'll get 10 square roots of 7 plus 10 square roots of 2 all over square root of 49, that's 7. Those two are canceling out, and they always will cancel out. That's the best thing about this. Subtract 2, because that's the square root of 4, right? So I would have 10 square roots of 7 plus 10 square roots of 2 all over 5. Now, these can simplify down. So I'm going to get 2 square roots of 7 plus 2 square roots of 2. Can't break it down any further, so that would be done. Now, if you would not see to break down those 10s and those 5s, that's fine. I will not count it off for you. But this is in simplest form right here without that 5. So let's do the same thing. We're going to multiply by the complex conjugate. So I'm going to multiply by the square root of 2 plus 1. So I'm going to get 5 square roots of 2 plus 5 over square root of 4 plus the square root of 2 minus the square root of 2 minus 1. So I'm going to get 5 square roots of 2 plus 5 all over 2 minus 1, which is 1. So that would be my final answer right there. And that's the end of this video. See you later, Sabers.